I want to show you a couple of equations where we solve for our variable and end up with a no solution or all solution answer. So to start these out, we don't really know what's going to happen with this example, so we just start solving like we normally would. On this first example, I see a set of parentheses, so I'm always going to distribute first. 2 times 3d is 6d. 2 times 7 is 14 equals 5 plus 6d. Alright, so now I'm going to try to get the variables. I have variables on both sides of the equation. I want to get those together. So I can go ahead and subtract 6d to make that cancel, and I'll subtract 6d from the other side. So over here on the left, that cancels like I wanted it to. On the right, we didn't intend for this to happen, but we noticed that we have a 6d minus a 6d as well. So that is gone. So what we just did is we started solving, and when we got our variable on the same side, they canceled each other out. So we no longer have a d to solve for. This means that we're not going to have a number for our answer. It's not going to be d equals 5 or d equals 7. So what do? We want to take a look at our equation and just continue working with it. What is it that we have left on each side? On the left side, we have a 14. Bring down your equal sign in the middle, and on the right side we have a 5. So now we're going to look at this equation and see if this is true at all. We're saying that 14 equals 5. So does 14 equal 5? It does not. That is a false statement. So if you end up with a false statement in the end, after your variables have canceled from both sides, that means that there is no solution to this equation. There's not a single value for d that would make this equation true, so no solution. And again, we knew it was no solution because 14 does not equal 5. That's a false statement. Alright, moving on to the second example. Again, we don't really know what's going to happen with this, so we just start solving. I see some parentheses, so we'll go ahead and distribute. 2 times m is 2m. And then you have 2 times, that is a negative 2 right there, so that's a negative 4. Bring down your plus 3 equals 2m minus 1. Now before I start solving, I want to clean this up a little bit. I do notice that we've got some like terms on this side of the equation. Let's go ahead and put those together. So we have 2m, negative 4 plus 3 is a negative 1, equals, and then you have a 2m minus 1 on the right. Now if we continue solving like we did on the other one, we would subtract 2m from both sides to get those together. You want to get your variable on the same side. Cancels on the left like we wanted it to, and then we notice that it is also canceling on the right. So we're solving an equation and we don't have a variable to solve for anymore. So that means that we're not going to have a number for our answer. And what do? We look at what we have left over. On the left we have a negative 1. Bring down your equal sign. On the right we have a negative 1. So the question is this true? Does negative 1 equal negative 1? Yes, it does. So if you have a true statement, that means that all solutions exist for m in this case. So you can plug in any value for m and this equation would be true. So m equals every single number that's out there, and so instead of saying m equals every single number out there, we just say all solutions. So if your variable is gone, you don't have anything left to solve for, it will be either a no solution or an all solution example. How do you know which one it should be? If what you have left over in the end is false, 4 does not equal 5, then no solution. If what you have left over in the end is true, negative 1 equals negative 1, all solutions.